All right, let's look at converting numbers written in scientific notation into numbers written in standard notation, which is what you're probably used to at this point. For example, here's a number written in standard notation. This is 356,200. Here's that same number expressed differently, expressed in scientific notation. It's 3.56 times 10 to the fifth. And what that means is really just what it's saying. This is not some cryptic, like hieroglyphic weird symbol meaning something obscure. It's really the number 3.562, 3 and then a little bit more than a half, times, multiplied by the number 10 raised to the power of 5, which is the same as a 1 with 5 zeros behind it, meaning 100,000. So 10 to the fifth is equivalent to 100,000. So really what this is saying is take the number 3.562 and multiply it by 100,000. That's all it's saying. And if you do that, you'll get this. So why are numbers written in scientific notation? Well, if they're gigantic numbers, it gets to be a pain to write it in the standard notation. Even a small number like a billion or a trillion, it's just a lot of writing. But there's some numbers we literally we would not have time to write them um, out by hand ever. You know, Astronomical distances. If you want to express something in kilometers, you know, you could not write down the distance from here to the most distant object we've detected. It's such a colossal number that it has to be expressed in scientific notation, or else we just can't write it down. Anyway, so it's just a convenient way to express very large or very small numbers. Okay, so let's convert some of these. Let's rewrite these numbers in standard notation. And what the idea is, it's pretty simple. If the base of the number is being multiplied by a positive power, 10 to the positive seventh, we just move the decimal 7 places to the right. If it's being multiplied by 10 to a negative power, we move the decimal places that many to the left. Now, why do we do that? Well, when you multiply something by 10, um, say you multiply the number 4 by 10, uh, you just take its decimal and move it over 1, right? Or if you're dividing 40 by 10, you just move the decimal place over 1 to the left uh, to figure out what that would be. So it's the same basic principle here, except not just 10, but 10 times 10 times 10 times 10, or you get the point. So we're either multiplying or dividing. Positive number we're multiplying, negative number we're dividing. Um, and you can remember, like 10 to the negative fifth is equivalent to 1 over 10 to the fifth. So it means we're dividing by 10 to the fifth. All right, so that's the basic idea. That's what's happening here. So let's just follow the rule now without too much thinking about it. So 4.2 times 10 to the seventh. We take our 4.2 and move that decimal 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. Okay, that's our new decimal, so we need to fill in between our places the zeros, and we can put some commas in there. So that's 42 million. Let me rewrite that. 42. 42 million. So yeah, I mean it's a lot more compact, right? 42 million, 4.2 times 10 to the seventh. Okay. 3.235 times 10 to the negative fifth. Now, this means we're dividing by 10 to the fifth. So we'll rewrite this 3.235. Now, since it's negative, meaning we're dividing, we'll move the decimal to the left. So 5 places to the left. 1, 2, 3, 4, 5. Here I didn't need to write my decimal. Here I do. If I don't, it would be hard to tell what number it actually was. So let me rewrite that. I write the bumps like that just to keep track of how many zeros I need to put in. So this is 0.0003235. Alright, what about 6.0511 times 10 to the negative third? So we've got 6.0511. We're multiplying by 10 to the negative third, which means we're dividing by 10 to the positive third. So we're going to go left 3 places. 1, 2, 3. So I'll fill in my zeros there. So rewrite this 0.0600511. Alright, last one. 5.107 times 10 to the fourth. 5.107 times 10 to the fourth. We're multiplying. This is a positive number, so we're going to go that many decimal places to the right. So 1, 2, 3, 4. You need to add a 0 there to show that place. So 51,070. Alright, so I've got 3 here for you to try. 3.78 times 10 to the negative 8. 9 times 10 to the 7th. And 6.1717 times 10 to the third. Good luck.